But I'm gonna, start going through this process, what some of these tools are gonna look like for us. So first things first, with kind of everything that we're gonna be using, we're gonna be using Metamask. Metamask is an injected browser wallet. Injected means it's a plugin. And here I am on one of the test networks here. But first things first, everyone's going to want to install this because it is the most widely used browser. It's easier than using a mobile browser, and they have the most documentation because they're the most popular to use. So it's going to be great for us starting out with our dev work. If you're using Chrome or Safari or really any browser, you can download it, and it's something you want to be careful about when you get it. So you definitely don't want to click anything that says like an ad isn't at the top of this the search bar here. But if you go into the Chrome extensions, this one has a few thousand reviews, 10 million plus users, definitely the legit one. So that's what we're going to want to download. I've already got it, so I don't need to, but if you don't, you're going to download that, and it'll prompt you, it'll give you your little plugin here in the corner. Click on the little fox, and it'll tell you to create an account. So you'll want to create a brand new one. It'll give you a seed phrase, and that seed phrase is something you are never, ever going to share with anyone. Never put it online. Never give it to me, never give it to MetaMask support, never give it to anyone. That's something you definitely want to write down on a piece of paper, keep it somewhere safe. It's basically the keys to your wallet. So I created a new little test account here that we're going to use. There's nothing really in it, but I have some test ETH. So once you have MetaMask, we're going to be doing stuff on the testnet. So just one more thing to show you on how we set that up is on your account, you're going to want to go into your settings. You're going to go into advanced settings, and you're going to want to show test networks. So if I turn this off, it's just ETH and Matic. Matic is for Polygon. I manually added that, so I could remove it if I want. But you're not going to be seeable in any of those. So if I add the test networks, then you can see your Ropsten, your Rinkeby, your Gurley, all those. And that's where you can kind of play around in the sandbox. So these are the ones we're going to use. You're going to need some Ether. You're going to need some gas to actually transact on there. So after downloading MetaMask, which I'm going to share this link in the chat here, this is for the Chrome web store. You'll have to find it independently if you're using Firefox or some other browser. But for testnets, there are faucets, which faucets just give you some free Ethereum, which is nice because this Ethereum isn't worth anything. It's on the testnet. It's not actually worth real money, but you still need it to interact. So the testnet is like a mirror of mainnet. So I'll show you guys what that looks like here. Just getting some test ETH. I can copy my account up here, drop it in here, and just say send me some ETH. I have an Alchemy account, so they send a little bit extra than if you don't make an account. It says they've had high volume lately, so they're making you authenticate. But Alchemy is a trustworthy website. They're pretty big in the industry, and they provide a lot of test ETH, so developers and people that are learning can get involved with the ecosystem. So it just said it sent me some, and it said I can follow the transaction. As we showed Etherscan yesterday, or last week, should I say, you can take a look at all your transactions and what's going on with them. So when you submit something, this is something to keep in mind for our front-end apps later. You usually want to offer people a link to, look at their transaction afterwards. And here, I'm going to drop this in the chat as well in case anyone wants to follow along, grab some test ETH for their Gurley testnet wallet. But, this is going to be pending. Ethereum transactions take a little bit of time. You can keep an eye on it, refresh it. Yeah, look, it's done there now. Status is success. It tells you the block. This is all the metadata from your transaction. From to, if you look at this, it ends in 6A4B. And if I pop up my wallet right here, that is my wallet. It ends in 6A4B. So this is, the destination was my wallet. And if I look here on my history activity, I just received this just now. So now I'm at 0.15. If you remember when the video started, I had 0.10. And you don't really need a lot of test ETH for deploying a contract or interacting with small things. Also, if we want to make our own NFT on the testnet and buy it, we can set the price real low, so we don't need to spend any of this. But this stuff's free, so you can come in here once a day and grab some that you'll need to build and such. And you can do that for other places as well. Maybe you want to use the testnet on Polygon. That's Mumbai is Polygon's testnet. You can do any of that. Mumbai is one you would have to manually add to your test network, but that's not something we're going to hop right into today. So, yeah, Curly, Rinkeby, Ropsten, Coven as well, popular ones that you can get free ETH for and test with. But past that, Metamask, need that in our tool belt for sure. Etherscan, need that in our tool belt for sure. We explained this quite a bit last week, so I'm not going to go too more in depth. But what else I'm going to be talking about today is going to be OpenZeppelin, which is an industry standard for contracts and code, and they are just a great, great place to get your foundation to build a contract from. They have tons of documentation. So we're going to look at OpenZeppelin. We're going to look at Solidity, the programming language itself. We are going to look at Remix, which is an IDE. We are going to look at Hardhat, which is a testing tool if you're using a different IDE. And then Hack3rs is a JavaScript library. So once we get into front-end mode, we'll need that. And then IPFS, of course. So sort of an image on what that might look like is this. So you as the developer, you're going to interact directly with IPFS to store your data. And that might look like metadata. What if I make an NFT collection? I need the names for all them. And maybe I want pictures to go with them. All that's going to go directly onto IPFS. And then you'll be making a front-end Dapp at some point. That's going to use an IDE. I have Visual Studio Code here, as that's the one I prefer. You can, of course, use anything there. And then we're going to use some React JavaScript, keep it real simple. React is the most popular JavaScript framework, so we're going to work with that for this series. Ethers.js. This is an important one. This is what lets you connect with the network. It is a library that helps you out with a lot of that. So you're going to need to manually, get your injected provider for MetaMask in there. But Ethers is what's going to let you interact with it and check some of those out. So I think I've got a link to Ethers somewhere, or the NPM package. So this is what we're going to be using. There are alternatives. You can use Web3.js or React.js, but we're going to stick with Ethers. It's kind of trivial which one you choose. They are really doing the same things. Some of them are just abstractions on top of each other with extra features, but super popular, tons of documentation. This is the one we're going to roll with. Back to our little tech stack picture. And here I'll drop this in the chat in case anyone wants that as well. All these links will be in here. When we do upload this, which it's going to be on YouTube to start, if you guys remember, we recorded last week's too, that it will be on YouTube. This one will be there as well. In the description, I'm going to throw all the links I show you in there, make things a little easier for you guys. So if you miss any of that. But we'll use Ethers to interact with it. And Hardhat is our testing suite for smart contracts, but that's actually going to be relevant for our front end as well. And then when we look at the stack for the smart contract, again, we're going to need an IDE. It could be Visual Studio Code. It could be Remix, which we'll touch on in a bit. We're going to need Hardhat because we have to test. We're going to need Solidity. That's our programming language. And we're going to need the Ethereum network. So the things you directly interact with, kind of looking like this, they're all split up a bit. So IPFS it's sort of your database. It's sort of your backend. You might need a legacy database, depending on your Dapp. You might need a Firebase or a MongoDB document database or something, but not all Dapps are going to need that, which is really nice. You're skirting the database, you're skirting the authentication. That can be really helpful if you're trying to move quickly. But this is what it looks like from the development side. From the user side, they're going to interact with your front-end Dapp. And through that front-end Dapp, maybe they'll read some data directly from IPFS, or through their MetaMask, they will interact with smart contracts and other items on the Ethereum network. So that's sort of what the user's abstraction looks like. A little bit simpler, less pieces, of course. MetaMask is the portal, or to most of the contracts and things they're going to interact with. Now that we have a bit of an overview on what that looks like as a whole, I am going to jump into Open Zeppelin here and show you guys that one. So as I mentioned before, this is our foundation. This is what we're going to use for the basis of everything we're doing. And they have tons and tons of documentation on all of it. So they break down all their tokens. They tell you how to install it. They give you links to their GitHub. This is all written in Solidity here. We'll touch on what that language looks like right after this. But yeah, so what their GitHub might look like for, if I want to jump in here and look at one of their contracts, I'm trying to make a token, I'll look at their token contracts. These are the industry standards for all of these. So, whether it's Bored Ape Yacht Club or Cool Cats or Goblin Town or any of these big NFT projects, their contracts are going to look something like this here. ERC 721.sol. .sol is the suffix used to signify this is a Solidity file. It confuses people sometimes because Solana's abbreviation is Sol and they're written in Rust, their smart contracts. But .sol means Solidity, so do not be confused by that. And as you can see, huge contract here, tons of functions, and at its base form, this is all you would need to deploy a smart contract. I'm sure you need metadata, but this is all you need here. You could, almost copy and paste this, which we're going to dig through this step by step when we write our first contract, which will be next week, and we're going to understand what all these functions do and what all the, why the choices are made to set them up the way they are. But at its base form, this is sort of all we need here. Now, yeah, they have docs specifically if you don't want to look straight at the code. A lot of these functions are explained to you. So balance of address owner, real basic docs here, just returns your address. You can go through one by one through these, but that's something we're gonna be writing one next week, and we're gonna do that together. So not to get too deep into this, I am gonna jump into Solidity as a language and what that looks like. So Solidity is a superset of Java. And if you are familiar with C or Java, you're definitely going to enjoy that because all the variables and operators carry over, and the syntax carries over. Now, there are some new variable types and a few new things that are specific to Solidity, and that might look like an integer /uint8. If I hop back into this contract, we will see some of that. Here, I'll go back to the GitHub one. That'll be a little easier to look at. So integer types. This is a uint 256. 256 characters allowed in this. Uint is unsigned and int would be signed. And you can have those in the size of 8 or 256 here. And that's just a little bit of memory optimization. If you don't need all that space, don't use it. That memory optimization won't really affect your efficiency in a Web 2 legacy Dapp, but when you're dealing with Web 3, space costs money. It costs money on chain because you need to spend more gas to write more data onto the network to fit into that block. So the more space you can save, the cheaper it's going to be for you to deploy, and the cheaper it's going to be for your users to interact with that contract later. So that's why we have a little bit more flexibility with memory with some of these variables. Another thing is this address. So an address is a variable type specific for Ethereum addresses. Now it knows you're going to take in a 0x and a bunch of numbers, just like this address up here is an Ethereum address. We have a variable for that now, which is great. You don't want to be type checking every time and making sure this is the right variable. So they do a little bit of the work for you. And that's why it's not too different from Java. It's more just like a superset. But we also have special global variables, a lot of special global variables, actually. And if you're dealing with transactions, blocks, and messages, you're going to get some of that. So let's check if this has any message functions in it. Let's see. These are ones they wrote themselves. Yeah. In this comment here, they mention it. So message.sender. Message is a special global variable. which means you can call message dot any of its traits in any contract, and it'll give you some of these details. Message dot sender is an address payable. That will always give you the sender of the message. Message dot value, that is an unsigned integer, and that'll give you the number of way sent with the message. There's also now, that is another integer, current block timestamp, and the transaction origin. Here's your address payable. So I'm going to drop all these in the chat here. These are just a few of them. There are more than this, but these are just examples of, these are tools you're going to use over and over and over. So Solidity has them, ready for you at the tip of your fingers, really. Maybe you want things about the block. You can get the block time. You can get the block number. And that block refers to, if we go back to our transaction hash, this block right here. We can get all the information about that very easily with a contract. So, built-in functions, really great for us. It makes it much easier to get any of this data because, if you're worrying about building out your contract, it is very helpful to not have to be an expert in, I need to create a variable for my block. I need to make sure it's type safe. I need to do this. That's the beauty of having a pre-built language or a custom-built language for this. Now, you might have noticed I mentioned before for the value, I sent message.value goes the number of way sent with a message. Way is a unit of Ethereum. It is actually the smallest possible unit. So 1 Ether is what we think of, as 1 Ethereum. Ether is the native token, but you can break that down into smaller pieces. Sure, you could have 0.001 Ether. And there are names for all of those. So 1 way is the smallest amount. It is one Ether equals 1 times 10 to the 18th way. And then you have K-way, which is kiloway, megaway, gigaway, and then a couple more all the way up until you're back to 1 Ether. So when we're doing a lot of transactions here, we're dealing with units at their absolute smallest size. So yeah, even here, when you look at base gas fee, 7 way is a fraction of a gwei, and a gwei is a fraction of an ether. So dealing with super, super small numbers here to avoid using decimals for more clarity. It would be very confusing if in our contracts we were writing about, writing with 10 decimals in talking about gwei, but then it's accidentally ETH. So by default, everything is going to be 1 unit. And that's probably going to look like gwei for you. So if you want to make something cost 0.3 ETH, it's going to look more like 3 million gwei is the actual price. So that will be something that takes a little getting used to in writing these contracts. You're going to put in massive numbers for very small amounts of ETH. But at least it's consistent, so we love that. Now, one more thing with Solidity is it uses the EVM. So Ethereum has its own virtual machine. Anything EVM compatible, you can add to your Metamask. So if I want to use native Avalanche tokens, I can add that network. If I want Binance, I can add that network to this wallet. And all that stuff's going to be compiled with Solidity. So it's not just Ethereum that uses Solidity. It's layer 2s and other networks use this language. But what the EVM does is, it breaks your code, this Solidity, this human readable code, down into machine code. And that's assembly language, really. So that's when you get into some more tricky stuff, a lot of hexadecimal, a lot of low-level opcodes. And you can even write in these low-level opcodes, but it definitely gets tedious to write in that sense. So I remember we had someone last week, if you're in here, just say hi, howdy in the chat, who's asking about opcodes. And that might look like instead of doing 2 times 2 plus 10, you would write 2 multiplication 10 plus. It's more pushing things onto a stack. So anyone familiar with your databases and pushing onto arrays or pushing onto stacks, that's what your low-level code looks like a little bit more, and that's what Solidity is broken down to for it to actually be used. So we're going to be using Solidity. It's just it's human readable is the point. We can understand this much more intuitively than we can understand those low-level opcodes. So I think that's a pretty decent overview of Ethereum. Just a few new variables we're going to use. We're going to have the same strings, the same arrays, the same data types in general. And when we're looking at our functions here, some of them are public. Some of these are going to be owner only. Some of these are going to be only for the owner, and that sort of dictates when I deploy this contract. If I deploy it with this address we're looking at, certain functions are only accessible when this wallet is interacting with the contract. And that's super useful because obviously I don't want anyone going in and changing my contract, but maybe I want to update the price. Maybe I want to update the metadata where the token URI is pointing. So there is a differentiation in this code between who can even use these functions. Now that we've looked at the language a bit, let's take a look at something exciting, and that's Remix. So Remix is an online IDE. You can also download this as a desktop app, but instead of using VS Code or something, all your tools are pretty much built in here. You've got a linter. It's natively going to support Solidity, and you can actually deploy in here. So you can create new workspaces. You can connect wallets. You can connect, fake test wallets, and you can compile your stuff in here. So once you get through there, you can deploy some of this stuff. I'm going to show you guys what just like a very, very basic Solidity function might look like. Now, if I want to hop into contracts, and I want to create a new file, whatever I name it, it's going to be .sol. As we remember, .sol is for Solidity files. And at the top of every file, you want to drop in a license identifier and your version of Solidity. So your license identifier is kind of like, in your README for any code, you might put an MIT license or a GNU, and that's sort of just stating, who can use this, is this code for use? Everything is public. When you publish the code on the blockchain, everyone can see it. As a feature of a public ledger, everyone's going to be able to see it. So, typically everything's kind of open source. Use it if you want. And that's super great for us since we're learning. We can go look at Bored Ape's contract and it's all visible. Everything's open source. But before we get to anything too crazy, we're going to do a very small function here. And this here is for our version of Solidity. This deals with the compiler. You don't really get too many compatibility issues because the developers keep that in mind. So our version here isn't very vital, but 0.8 something is what's typically used. So we're going to go 7 to 9 is what we're accepting with this. Now, we're going to create a contract called storage, since that's the name of our file here. And, just like C, just like Java, we might want to declare our variables. We'll do a uint 256 and just set a number. Now, we might normally just do int number, but we want to specify it's unsigned and we want to let this number, really be whatever size it is. So we're going to use these Solidity variables, not really relevant in basic functions like this, but it's good practice to have because you're going to be a little more type safe on larger levels if you're specifying whether the int is signed or not. Your security here is very important because these are not editable contracts once they're deployed, and there's usually money involved with these. So, freestyling is fun when in a sandbox, but when you're actually deploying things for real, it is best to use industry standards. That way people can audit your code for you, take a look at it. It's easy to understand. You don't want to be stuck in a spot where no one looked at it because it was written weird and then you deployed it and you get some hacks. So past that, we're just going to make 2 functions in here. We're just going to make a function to store a number in this contract, and we're going to make a function to read that number. So it's just going to be a read write, really. And once this contract's deployed, anyone will be able to go interact with it, save a number to it, that's going to cost some gas. Writing to a contract costs gas, but we're sending such a small amount of data that it's almost nothing. So what that function is going to look like to store it is we'll write function store. We need to take in a variable. We'll take in a uint 256 because that's the number we're dealing with up here. We want to keep our variable types the same. Call this num. And as I told you before, there were some owner-only contracts. Well, we want anyone to use this. So we're going to make this thing public. And let's make a function down here as well to retrieve it. So function retrieve, and we don't need any params here, but we'll call this public view returns. And I'm going to kick back the same variable type, a uint 256 here. Now we will take this input num, store it in our local variable here. So we'll do number equals num. And super simple function. This is just a getter. I mean, this is just a setter, and we just have a getter down here. So, again, nothing groundbreaking for you guys since most of you are developers, but we're going to keep it simple just to see mainly how this IDE is going to interact with this function. And then down here, all we want to do is take this number here and kick it back to the user. So we will return our number there. And it looks like this is all we're going to need here for this function. So if we go down to tests, we can write a test for it. We can use some of these scripts, but we're not going to be careful today. We're just going to try to compile it. We're going to be a little risky. And what's nice too is, we can auto compile this stuff, but we can hop in here, manually compile it. We can use this terminal to upload some stuff to IPFS, which, as you remember, IPFS is our little database here. But mainly, we can hop down here to deploy and run, and we can actually launch this right here. We can launch this onto the network from here. So injected provider Metamask, I can use this to actually connect to my Metamask that's in my browser. And, I'm on the test network here. But if I were on the mainnet ETH network, I can launch a contract right now, which is super easy. This IDE is doing a lot for you, and it's an IDE built just for Solidity. So that's something that's really great to have. I can connect, as you see, 0.15 Ether. It's reading directly. It has access to my wallet. But what we're actually going to do is use the Remix virtual machine. And that's just going to give us a bunch of fake wallets here that we can do whatever we want with. So, I can pick a random one of them. I can go to this contract. This is the one I just wrote, storage contract / storage.sol. And I can deploy it here. Now, with that, you'll see the transaction hash down here, just the way we saw the transaction hash when, we use this faucet to get some ETH. And let's see, transactions recorded, deployed contracts. We now have a storage contract we can use. So here are the two functions we wrote. We got store and we got retrieve. We can interact with them. So if I retrieve now, it's got nothing in there. But if I want to put the number 55 in here and store it, if we look up here, we used a little bit of gas, by the way. We've stored 55 in here. If I retrieve again, it's got the value 55. And we can read that same thing going on our terminal here. But that's what it really looks like to, use an IDE built for Solidity, write a small file. I mean, if I were to deploy this on mainnet, anyone in the world could go interact with this contract, store a number, take it out. Doesn't sound very useful because it's not, but when we build some more complex stuff, it's going to be great that we can so easily deploy something that anyone in the world can interact with based on, the set functions we give them. And these are both public, but, put any numbers in here, read them out. There we go. And we're not using a database. We're using the blockchain. So instead of reading and writing to, your Firebase or your SQL database, what we're using as a database is the blockchain, which can get pricey for some things, but is beyond convenient for others. So that's a basic look at Remix, one of our main tools. If we don't want to use Remix, which I think there are some other exciting options. And when we're building a larger project than this, what we will actually be using is Visual Studio Code. It is a very lightweight IDE. So, if you're thinking, why would I use that when all these tools are kind of pre-built into Remix? Well, if I want to test on the front end, Remix is kind of existing on its own out here. It's just for smart contracts. What I could do is hop in here and create React app and make myself a front end project and then work within that. And that's where Hardhat comes in. If you guys remember, I mentioned Hardhat a bit ago. This is kind of like your Swiss Army knife for building projects outside of Remix. It has all of Remix's tools built in for you here. So I would have to npm install Hardhat. I already have that installed. I'm just going to show you what it looks like when you install it. So let's assume there's a create React app here and I'm working within some front-end JavaScript project. I would run npx Hardhat, and Hardhat is going to set up that environment for you. What do you want to do? I'll opt to just create a basic sample project. Project root, this is the folder I'm in right now, episode 2. And sure, we'll add a git ignore. And boom, it's going to create contracts, scripts, test. That looks very familiar. It is exactly the breakdown we're looking at over here. Contracts, scripts, tests. Now we have all of those tools right here in our Visual Studio Code. So, these folders could all be inside your Create React app. Now let's say I want to run Hardhat node in the README here. That's where I'm getting all these files from. It tells you, all your commands. But if I run Hardhat node, boom, look at this. I have a bunch of sandbox accounts to play with too. Now I can deploy from these accounts the same way I deployed something from one of those accounts in here, it gave me all these accounts. I can play with all those, but what's extra cool is it's giving me the private keys. These private keys don't really point to anything. It's fake accounts. It even tells you right here, there's nothing really in them. It's localhost stuff. But what's very exciting is I can take one of these accounts, take the private key, and I can hop into my browser from there. And I can add this wallet on my localhost. So if we remember all the way down here, there was a localhost. When I am running a front-end app on localhost 3000, I'm still in the dev environment, I'm still working on it, I can create a parallel localhost for that where I can interact with my contracts in my dev environment and get everything set up right there. So that's sort of the power of using Hardhat, is you can use it inside your front-end app, not have to worry about, maybe I'm switching back and forth between Remix and Visual Studio Code. You can have it all in one place. And we're going to be building some full stack stuff, so that's going to be very important to have. Now, we're at 10:36 here. I do want to pause and see if anyone has some questions about what we're talking about. Like, has anyone used some of these tools maybe? I know I just threw a lot at you, but just for us to look at it again so some of it can sink in. Mainly, we're going to be using an IDE with Hardhat, with Solidity, and then on the front end, we're going to be integrating our Metamask, and we're going to be integrating a JavaScript library. So we've got about a half a dozen tools here. It is kind of a lot. Kim said most of them are new. That's super exciting then. You're going to get to learn all of them at the same time, and they do integrate really well. As I just mentioned, this is everything you have in Remix, which is custom built for it. Solidity is a custom built language for Ethereum. It was created, I believe Charles Hoskinson created it, he now runs Cardano, but he was one of the founders of Ethereum with Vitalik Buterin and Gavin Wood. So, these guys created this stuff custom for Ethereum, which means the tools integrate super well. Now, the last tool that we didn't mention is going to be Pinata. Pinata is one of many ways to connect with IPFS. IPFS is an on-chain database. You store your data on there. But, there are other ways to deal with it, to get stuff on IPFS. This is a really user-friendly way that I found to do it. So, pinata.cloud. I'm going to throw that in the chat here in case anyone wants to look at it an hour later. Effortless IPFS file management. So yeah, this is something I uploaded 7/18 last night. This is a hash, so I'd be able to find it if I did IPFS/these. I can reference this in my front end app and pull data from there instead of from a database or locally storing it. And this is just an image, so you can put images up here. You can put metadata up here. This is what we're going to use later when we are creating our NFTs. We need to store that metadata somewhere so the contract can reference it. Well, there aren't any parameters here, but if I created a function that took in some parameters, this is where I would put them in. Before deploying it, maybe I'll put in this hash. Maybe I need to copy this and put it in here. That way, when my contract's deployed, I'm manually putting in that data. Hey, this contract points to this metadata at this location on IPFS. This immutable data, once this is up here, I can't change it. This hash will forever point to this picture. And that's what's nice about blockchain is, you put it up once, it's immutable. You don't have to worry about some centralized service saying we're going to take it down. It's all in your hands once it's up there. So that's really a full look at our set of tools here. That's just about everything we're going to use. There are some bonus tools that, I'll throw one of them in the chat right here if anyone wants to, go look at it on their own. But, we're going to use Rainbow Kit at some point. And, that's a third-party open source software to connect your wallets. So maybe you want to use, as I mentioned last week, there's different types of wallets. Maybe I want to use a mobile wallet. Maybe I want to use Coinbase wallet instead of Metamask. If I'm creating a Dapp and I want my users to be able to connect to all of those different wallets and not have to use Metamask to interact, I can offer that. So, there are bonus fancier tools, but these are the base level things that we're going to need to use. And there's one more thing I want to show you guys. So this is a tweet I came across the other day, and it has incredible standard operating procedures for launching an NFT project. So this user here, Winter, posted this, and this is their SOP for creating a contract. Now, I'm not sure if everyone's able to see this, so what I'm going to do is copy the image address and throw it in the chat. So if anyone wants to look at that, they can. But it's really great here because this is sort of what our SOPs are going to look like going through this. Preparation, pick the NFT type, 721 or 1155. Pick the chain to deploy to. We're going to be using ETH. Use the latest Solidity compiler. And then when you get to the minting process, how are we going to do that? We have to limit the supply. Split sales and core. Maybe some core NFTs. Maybe we're going to save 10 NFTs for the team. And maybe we'll save 40 more for partnerships. We want to give them to projects we partner with. How do we set those aside? And how do we remember to do that? Avoid reentrancy bugs. Handle refunds. So this is kind of a checklist of everything you're going to want to do in this process. Admin functions, pull the money out, reduce the supply. These are the owner-only functions we talked about. Testing it, deploying it after launch. So just another resource I want to give you guys, incredible SOP for deploying a contract, and I want to give credit where it's due also. This user, Winter, posted it the other day, and yeah, just awesome. So I wanted to show you guys for the tweet in there too. I find it very helpful to, follow developers on Twitter and stuff, be in communities with developers. That's what you guys are all doing by, watching these videos and being in the Discord, is you're engaging with these communities. And that's where you learn this stuff, because, you can't really learn it all alone. So learning it with some people is the best way to do it. But now that we've gone through everything we wanted to for our tools and our tech stack and looked at how to use some of those tools, I want to ask you guys a few questions. So one is, are you guys more interested in Remix or VS Code paired with Hard Hat? So this, it doesn't have to be VS Code. It could also be anything. But Hard Hat would, manually throw some of this stuff in. This is just a config with, your version and all this stuff. But if we look at Remix, that's the built-in one where you don't really have those front-end capabilities, but it's a little bit easier to just deploy something quick and dirty. I want to know, what's your level of interest using either of these? Would you like to learn both? If so, we can use Remix at first for just our contracts. And then when we get to the point where we're doing full stack dApps, when we're building up this front end, that's where we're going to need to jump in and use Hard Hat and use some more proper testing with our front end. So we can absolutely use Remix to start and then later migrate some code over and use Hard Hat in the future. Totally a possibility. And then, where would you like to watch our recorded videos? I mean, I know I told you guys we were going to stick them on YouTube, but that's something we're still figuring out. So if you guys think we should host them somewhere else, if you guys have problems watching stuff on YouTube, let us know. We are open to questions there. And, anyone, if you have answers for these right now, throw them in the chat. I'll post all these questions afterwards too. And, maybe just create a thread on them in general so people can answer under these. But, you got an answer now, throw it in there. Love to hear it. If anyone's used any different tools, let me know. If anyone's dabbled in their dev stuff a little bit and, they use something else, Hard Hat's not the only tool for what it does. You could also use Truffle for that. Brownie's a popular one with Python. People definitely do some stuff with Python that's Web3 adjacent. I know I use Python when I'm doing metadata generation. And that's a big one that I'm going to throw in the chat as well is, do we want to do a webinar on art and metadata generation? That might sound like it's not really relevant to Web3, but it is when you look at NFTs, which are something we're going to be building for our project together. So when you make an NFT collection, like I said, you have to go on Pinata and upload some metadata for it. And if you are doing full service for a project, maybe you find a client that wants to hire you to help build the tech side of their NFT project. You got to get that NFT You got to get that NFT's metadata created and up there. That metadata is like what we looked at on OpenSea. So all of this stuff these are metadata traits, and there is a JSON file somewhere that is providing all this information. And they had to generate that as the art was generated, so they were linked together. So file number 7429 in the JSON had all these traits, and it pointed to file 7429 for this image. So those things are paired together. And if you ever have a client that wants you to build the full thing end to end, they're going to ask you for metadata and images. So could be a cool thing to learn. Kim's down for it. That's awesome. Yeah. I'll get some more opinions from, the rest of the gang in the Discord, and we'll see. But, it might feel like a detour, but on the path to becoming a full stack dev for this stuff, it's going to be, necessary. It's something you'll learn at some point. Yeah, so that's something I look forward to. That's going to affect our trajectory of what order these lessons go in. And, if we stick in a special episode, just for metadata generation. Again, this is a community-driven process. So what you guys want to learn is what we're going to learn, and we're going to pivot and change our course depending on that feedback that we get from y'all. So anyone who was here last week and you're here again, thank you so much. Anyone who's watching this on YouTube next week or next month or anytime, thank you so much for watching. I want to open up the floor here for anyone who's in this call right now. Maybe tell us what you're excited to work on, what your thoughts are, if you're lost, if that moved a little too fast, if you understand this stuff, or even just like what you like to do in the space. So, maybe you flip NFTs, that's what you do. Maybe you're working on your own project. Maybe you're interested in physical infrastructure with some blockchain stuff. Whatever it is, if you, like to come, up on stage here, I suppose you can raise your hand in the chat, and we can give you the option, the ability to come talk to the group here. But anything you're working on, this one and in future ones, we'd love to hear about it, because it is really about you guys here. This is why we're doing these. So, if anyone wants to throw something in the chat, let me know. Otherwise, past that, like I said, all these questions I just asked, we are going to be dumping them in the general chat, and getting opinions from y'all, because we are fluid with our path. We've got that curriculum set, but we totally have space to throw in surprise episodes for, maybe we want to dive into Merkle trees and see what those look like for saving data. We're definitely going to stray off the path here and there. But if we've got no questions, no one wants to come share their project, then I think that's going to be all for this week. Again, thank you all so much for joining. I hope you learned something today, and I'm very excited for next week because we are going to start coding, and coding for real, not just doing a little getter setter function in Remix. We're going to do some real coding next week. So keep your eyes peeled for that. It's going to be Tuesday, 10 a.m. Mountain Time, same time. And until then, be good, guys. Let me know your feedback. Bye.